All right, guys, back at it. Had a couple problems to get through today. Okay, we're still dealing with these trigonometric expressions and manipulating them. Okay, so this guy right here, sometimes having the ability to do this is really helpful. Will come into play down the road. But taking a fraction that's made up of trigonometric expressions and rewriting it so that it's not a fraction. Now, this guy gives us some problems here. Okay, notice that the numerator is a monomial and the denominator is a binomial. Now, if it was the other way around, if it was like this, 1 minus sine theta all over cosine squared theta, the very first thing I would do is I would distribute that division. Okay, and so I would write that as 1 over cosine squared theta minus sine theta over cosine squared theta. Okay, I would go that route. The problem is that it's not like this. Okay, so we have a binomial down below in the denominator, so there's no way to distribute that division because there's only a monomial up in the numerator. Okay, so this is not going to work. Okay, so one thing that works sometimes is that if you use conjugates. Okay, so remember a pair of conjugates, okay, are binomials. Okay, so conjugates. Okay, you would have a pair of binomials that are exactly the same other than their signs. Okay, so for instance, you would have A plus B and A minus B. Okay, that would be a pair of conjugates. And when you multiply conjugates together, you always get a difference of squares. Okay, so why not try this? Why not say, hey, let's multiply down below by the conjugate of 1 minus sine theta. So that'd be 1 plus sine theta. And so if I do it down below, I've got to do it up above. Okay, so 1 plus sine theta. Okay, let's see if this works. Okay, so up above, I have cosine squared theta times 1 plus sine theta. Okay, all over. Now when I multiply these together, I get a difference of squares. So I get 1 times 1, 1 squared, or 1, minus sine squared theta. Okay. Now this guy looks really interesting to me because I see a 1 and I see a sine squared, so I think of my Pythagorean identity. So if we go to our first Pythagorean identity, okay, and I'm thinking about that guy right there, we know we get sine squared theta plus cosine squared theta equals 1. Okay, so if I would, but I need 1 minus sine squared, so I'd have to move that sine squared over to the other side. So I'd get cosine squared theta equals 1 minus sine squared theta. Okay, so that means this denominator is the same as cosine squared. Okay, so let's substitute cosine squared in there. Okay, so I have a cosine squared theta times 1 plus sine of theta up above all over cosine squared theta, and notice they cancel each other off. Okay, so this reduces down to 1 plus sine of theta. Okay, so notice, are we done? We rewrite so that it's not a fraction. Well, it's not a fraction anymore, so we're in good shape there. Okay, first one down. Second one. All right, so notice again, we're in a very similar type situation where, again, you know, I can't distribute division here because the binomial is down below in the denominator. If I could switch those guys so the secant x minus tangent x is up above and it tends down below, then I could distribute the division to each, distribute the division by 10 to the secant and tangent, and I'd go that route, but we're not in that situation. So again, the binomial's down below, so again, it might be similar to this. So why don't we try using a conjugate? Okay, so let's see if that works out. Okay, so the conjugate of secant x minus tangent x would be secant x plus tangent x. And if I multiply down below, I've got to multiply up above by the exact same thing. Okay. So I'm going to get 10 times the quantity of secant x plus tangent x all over, remember anytime you multiply conjugates, you get a difference of squares. So I'd get secant squared of x minus tangent squared of x. And then this guy right here, again, I see secant squared and tangent squared. So I'm going to go to my second Pythagorean identity and see if I can do something with that. Okay, so that Pythagorean identity, tangent squared of x plus 1 equals secant squared of x, like that. And can I manipulate that? Well, I need to have secant squared minus tangent squared. So if I move this guy over, I get 1 equals secant squared of x minus tangent squared of x. So that means this denominator is just 1. Okay, so we get 10 times the quantity of secant x plus tangent x all over 1. So that just reduces down to 10 times the quantity of secant x plus tangent of x. Okay, now there's nothing wrong with leaving your answer like this. That's 100% correct. Okay, if you wanted to use the distributive property, we could write this as 10 secant of x plus 10 tangent of x. Okay, so either one of those, okay, would be 100% correct. And again, notice all it's asking us to do is rewrite it so that it's not a fraction. Well, it's not a fraction anymore, so we're in good shape. Okay, try another one. All right, let's see. Well, it's the same situation. Okay, so once again, I'm thinking I got to use conjugates. Okay, so if I multiply that denominator by its conjugate, that would be cotangent theta minus cosecant theta. So if I do it down below, I got to do it up above. Okay, cotangent theta minus cosecant theta. Okay, so let's see, we get 2 sine theta times the quantity of cotangent theta minus cosecant theta. Okay, all over, let's see what happens here. Okay, that would give me cotangent squared theta minus cosecant squared theta. And I see that cotangent squared and cosecant squared together. Okay, so I'm going to go once again to my Pythagorean identities, and let's see what I got down here. Okay, so I have cotangent squared of theta plus 1 equals cosecant squared of theta. Okay, now I need to get cotangent minus cosecant, so I need to bring this guy over to get cotangent squared minus cosecant, which means this guy has to go over. Okay, so I would get cotangent squared theta minus cosecant squared theta equals -1, which is what I'm looking for. Okay, so that means this denominator is equal to -1. Okay, so I get 2 sine theta times the quantity of cotangent theta minus cosecant theta all over -1, which just reduces down to the opposite of 2 sine theta times the quantity of cotangent theta minus cosecant theta, like that. Okay, so that's one possible answer. Okay, I don't know if that's the best one or not. Okay, because I'm thinking, can I simplify this if I distribute sine? I think I can. Okay, here's the reason. Okay, cotangent is cosine over sine, so that'll cancel. And cosecant is the reciprocal of sine. So how about if I take these two guys and write it in terms of cosine and sine and see what happens? So -2 sine of theta. Let's see, cotangent would be cosine theta over sine theta, minus cosecant is the reciprocal of the sine, like that. Okay, so now if I distribute this sine, -2 times sine times cosine over sine. Notice the sines cancel on the diagonal, so you just be left with cosine of theta, and then sine times, well, I just get 1 minus 1. Okay, so we take a look here, and then we look up here and we compare them. Certainly this guy is simpler. Okay, so certainly this guy is definitely better. There's no doubt about it. Okay, this is a better form of the answer. Okay, so we could leave it like that, or, okay, we could distribute the 2 if we wanted to, and let's see, that would give me 2 minus 2 cosine of theta. I would say these two guys are definitely better, okay, because they're simpler, okay, than this guy. So although technically, I guess this guy is good, okay, you want to definitely gravitate towards these guys. Okay, good shape there. All right, let's see this guy. Okay, we'll get this guy done today. We'll probably take a look at a couple more of these guys tomorrow. Simplified by combining fractions. Okay. Well, if I'm going to combine fractions, I need the same denominator. Okay, so let's see. I look at these two denominators, and that means I'm going to have to combine it into one whole fraction, and that denominator has to have a factor of cosine, and it has to have a factor of 1 minus sine. Okay, so down below, I'm going to have cosine of x times the quantity of 1 minus sine of x, like that. Okay, so if I'm going to do that, over here I have to multiply above and below by cosine. So here I have to multiply by cosine of x and cosine of x, okay? And here I'd have to multiply by 1 minus a sine of x. 1 minus sine of x and 1 minus sine of x, like that. Okay, so let's see what happens here. Okay, so cosine times cosine is cosine squared. Okay, plus, notice this would be 1 minus sine of x times 1 minus sine of x. Like that. Okay. So I am thinking that maybe I ought to expand this guy. Okay, so let's see what happens if I do that. Okay, so I've got a cosine squared of x plus, let's see, that's the square of a binomial, so take first term, square it, 1, bring the sign down, minus 2 times the first times the second would give me 2 sine of x, okay, plus second term squared would give me sine squared of x, like that, all over cosine of x times 1 minus sine of x. Now I'm looking at this guy, and I'm thinking, okay, what if I take this guy and group it together with this guy? Okay, and I'm thinking going back to my Pythagorean identities, the very first one right there. Okay, so I know I have this. Sine squared x plus cosine squared x equals 1. So if I group these two guys together, sine squared x plus cosine squared x, okay? Then I notice I'm still gonna have 1 minus 2 sine x. All over cosine x times 1 minus sine x. Okay, well this guy is equal to 1. Okay, we know that. So this is a 1, which I can add with that 1. Okay, so I get 2 minus 2 sine x all over cosine x times 1 minus sine x. Okay. Now notice up above we have a common factor of 2. So what if I pull that out as a GCF? And I'd be left with 1 minus sine of x all over cosine x times 1 minus sine of x. And notice that the 1 minus sine of x cancel off. So goes away, goes away. And so we end up with 2 over cosine of x. All right, now, technically, that's an okay answer, but we can get rid of this fraction by taking the cosine down below and bringing it up above and changing it into its reciprocal, because 1 over cosine is a secant. So this would be the same as 2 secant of x. And that guy is better, okay, than this guy because it's not a fraction. Okay, so I like this guy better. Okay, no doubt about it. Okay, technically, you know, numerically, you're correct right here. There's nothing wrong with that, and we certainly have simplified this down to here. Okay, and that's a good thing. Okay, but we could keep going and get rid of you know, the fraction bar. Okay, and rewrite it as 2 secant of x, which is better than this. Okay, so that'll wrap it up for today. Okay, I'll be back tomorrow with some more videos. Okay, you guys make sure you stay safe out there, and I miss you a whole bunch.